Hi everyone, Francis is here. In today's video, we'll be taking our second example, continuing from where we left off. We're looking at partial fraction decomposition as a topic. So here we have an example, and the example says, write a partial fraction decomposition of x squared x raised to the power 4 plus 2x raised to the power 3 plus 6x raised to the power 2 plus 20x plus 6 over x to the power of 3 plus 2x to the power of 2 plus x. So with what we have here, like I said in the first example, to solve this or to work this out, we'll look at the partial fraction given and determine or ask the question, is this a rational partial fraction or an irrational? In this case, we'll have an irrational partial fraction. And as as you may know, an irrational partial fraction is a fraction such that the function I have at the numerator, or the x power of the function I have at the numerator, is greater than the x power I have at the function I have at the denominator. So with that said, you can see that x raised to the power 4, the power of x here, the highest power of x I have at the numerator is 4, and the highest power of x I have at the denominator here is 3. So the highest power of x at the numerator is greater than the highest power of x that I have at the denominator. This is an example of an irrational partial fraction. So what do we need to do when we have an irrational partial fraction? Think of it as having 3 over 2. And whenever you have 3 over 2, you can express that in a rational sense as one whole number, 1 over 2. That's the same thing we're going to do here. So doing that here will mean to divide this with, divide what you have here with the denominator. When you do that, that leads us to a topic you will have treated before, which is long division of polynomials. When I divide this by this, doing the long division of polynomials, I'll spare the details. It's in the earlier videos we have treated here. Would have, x whole standing alone, with this as the divisor, and 5x raised to the power 2 plus 2x plus 6 as the remainder. So with this now, our next step will be we now have a rational partial fraction to work with. So the next step will be to decompose this rational partial fraction. Now, to do that, recall that we'll look at what we have at the denominator, like I told us earlier, and then factorize. If it's already factored, we'll go over to decompose. If not, we'll factorize. Okay, so when we factorize this expression, when we factorize what we have at the denominator here, this function we have at the denominator here, would have x into bracket x plus 1 raised to the power 2. Okay, now to move on, observe that what we have at the denominator here is an example where we have a repeated root. We have a repeated root and one linear root. The x here alone is an example of a linear root. You can think of it as x plus 0. Okay, it's linear. So writing it, the short form will just be, when you write it as x, it's also still linear. So what we have here, what's it called here? What we need to observe here is that we have x plus 1 and x plus 1. So this is a repeated root, and you can see it having x plus 1 raised to the power 2. Unlike what we had in the previous case where we have 2 distinct linear roots. This is a case where we have one linear and two non-distinct or 2 repeated roots. So how do we break this into parts at the denominator such that we can write our unknowns at the numerator and then work it out? So what we need to do first is for the first denominator we'll write x. The next one we'll take what we have at the numerator. The unknown that will be at the numerator will be a constant, as we know, because this is a linear factor. The next will be to write. We distribute this. We think of this distributed in form of a power, in form of we try to distribute it geometrically. We try to distribute it. If we had the power of highest power of, if this were n, what we have would be x plus 1, x plus 1. The next one will be x plus 2. The next factor will be x plus 3. We'll keep going on and on like that. Distribute it, we'll have till we get to x raised to the power n. So, but in this case, what we'll have at the highest power here is just 2. So we start by, writing the first linear factor to be x plus 1, and the next denominator to be x plus 1 raised to the power 2. Then at our unknowns, at the numerator here, we represent, we'll write our unknowns, which is what we are trying to look for, or what we want to find, A, B, and C. Having done that, the next step will be to take find the lowest common multiple of the right hand side. When we do that, we would arrive at x plus x plus. So in other words, the lowest common multiple will be the same as what we have at the left hand side here, x into bracket x plus 1 raised to power 2. That's what we're going to have here. And we'll multiply both sides of the function of these expressions by x into bracket x plus 1 raised to power 2. Would have just the numerator left. We'll have this expression 5x plus 20x plus 6 on the left hand side, and what we'll have on the right hand side here would be x into bracket x plus 1 raised to power 2 plus bx into bracket x plus 1 plus cx. So with this said, the next step will be there are two ways we could do this. We could solve this by collecting like terms as we did in the first example, or we could also go by, say, eliminating, using the formula, using a method called eliminating the coefficient elimination, or eliminating the coefficients. But let's see. So here we would use what is called eliminating the coefficient. Will mean we'll look at the expression we have on the right hand side here and see what values we can give to x such that would have 0 here and multiply when we have so that this expression can be 0, or so that this expression can be 0. Okay, that is what it means to use elimination or coefficient elimination method. So what value would make me have 0 in this bracket, or 0 here, or 0 here? If I'm thinking of wanting to eliminate this, or if my aim is to eliminate this or this, the value that will give me 0 here in this bracket will be x minus 1. And when I put in x minus 1 here, I'll have x minus 1 plus x1, and that's 0. When I put in x minus 1 here, I'll have x minus 1 plus x minus 1, and that will be 0. So multiply this by this will be 0, multiply this by this will be 0. I'm only left with what? When I put in x minus 1 here, I'll have minus c. So that's what you have here. So that x minus 1 kills this. I will only be left with c into brackets minus 1, and then with this on the right hand side. Substitute the same x into this position, substitute the same x minus 1 into this position, I'll be left with this. When I do the arithmetic here, okay, when I do the arithmetic operations here, I would have minus 9 is equal to minus c. So with that said, divide both sides by minus 1, we'll have c equals to 9. So we succeeded in getting what the value of c here would be. So our next goal will be to using the same method, eliminating the coefficient method. We look for what expression we'll be able to find c. Now we want to eliminate c here such that we can find the a and b. Now to do that, what value would x take for me to have all of this to be 0? X has to take 0. And that's why I had to say let x to be equal to 0 here. When I make x to be equal to 0 here, I substitute x into the whole of this expression I have here. I substitute x equals to 0 into the expression I have here. And when I do that, I would have we will have this expression 5 into bracket 0 raised to power 2 plus 20 into bracket 0 plus 6 is equals to a 0 plus 1 raised to power 2 plus b into bracket 0. All of this are the expression we're going to have. So since I have 0 here, b times 0, all of this goes. C times 0, all of this goes. So I'm left with 0 plus 1 in the bracket. When I square it, I still have 1. 1 times 1 is a. So this is the only unknown left, a. So when in fact, from what you can see here, a will be the only unknown and a will be equals to 6 because this will be 0 and this will be 0. That's why we have our a here. We found out our a to be equals to 0. Now, having found our a and we found our c, okay, we're only left with one unknown to look for, which is b. Okay. So since c is equals to 9, since c equals to 9, a is equals to 6. What do we need to do to find what do we need to find b? Okay, so we can just let x to be 1, and the reason we want to let x to be 1 is since that's the only unknown, we don't want the b to be we don't want to give it x a value that will make b to be 0. So we can give it 1. You can choose to give it any other constant, provided it makes all of this to be non-zero. So x for which all of these factors or all of this value will be non-zero can work. It's not just 1 alone. But for simplicity, we'll just take 1. So when we put in 1 here, we'll have 2. Put in 1 here, we'll have b times 2. And that's the expression we'll have here. So when I do the same thing here, when I substitute the same 1 to be into this expression here, I'll have a times 2 raised to power 2, and the expression here will be 4. So we'll have 4 in the bracket. And since we know what our a is, we'll substitute our a here, and the expression here will be 24. So without sparing you the details in the arithmetic here, we know what substitute 1 into 9. We substitute 1 into this into c here, and we're into the equation here, and also 9 into c here. We'll have 9 times 1, and though we are left with just b to be the unknown, and when we do the arithmetic, we'll have b equals to -1. So with that said, we've been able to get what our a, b, and c, the constants, what our a, b, and c would be. So what's the next step that follows will be to just substitute that value of a, b, and c, and boom, will be done, and that will be our expression. We've succeeded in finding the partial fraction decomposition of this expression. But however, let us also, this one method you might want to use, but there's a simpler method just in case you're running out of time and writing exams and want to have your A, and you want to maximize your time. You might want to use a different method. Rather than using the elimination method, you might want to try to use the earlier method we used, which you can call collecting terms, or whether it goes by different names, but I will show you that here. So from what we have here, this expression is equal to this. So what we have from here, open up the brackets. Okay, just the same way we did in our example 1. Open up the brackets. When you distribute a, when you open the brackets here, you have x squared is equal to 2 plus 2x plus 1. And then when you distribute a into this expression, you will have ax squared plus 2a plus a. So you also do the same thing here, and then you have these factors. You have bx squared plus bx, and then these are c. If you recall in the previous lecture, in the previous lesson we had, where I use a term here. When we have an expression of this nature, what we need to do is add apples to apples, oranges to oranges, bananas to bananas. In a loose sense, it's just collecting. I'm only just saying this in a loose sense, but you actually just collect like terms or collect terms. So 5x squared, look for terms that all have the coefficients that have x squared in them, and then equate them with 5x squared. Look for the term that have 20. We have 20x here. Look for the coefficients of x here, and then equate it with 20x. And that's this. For reference purpose, I'll call this equation 1, and this I'll call this equation 2. We're left with a term here. Look for any constant here and equate it with 6. The only constant we have in this expression, the only constant we have in this expression is a, when a multiplied by 1. So it's a. So in other words, our a is equals to 6. So having found one of the unknowns, that information can lead us to find other unknowns. Okay, so having found this, we can use substitution method. We can substitute our a into equation 1, okay, which we can think of as 5 equals to a plus b. So when I substitute 6 into a, I'll only be left with b as unknown. So I'm left with b is equals to 5 minus 6, and that will give us b is equals to minus 1. Okay, now we found our a and b, we're only left with c as the only unknown. When I substitute a and b in this expression, okay, the only unknown I'm left to find is c. And when I do that, you will see that c is equals to 9. So with all of this, I'll go over to expressing that our partial fraction decomposition, which is what this we're given, okay, it's equals to 6 all over x plus minus 1 over x plus 1 plus 9 all over x plus 2 raised to the power 2. So this is partial fraction decomposition of this expression. But mind you, we're given this to decompose this. So in other words, if I want to write the partial fraction decomposition of this, I would write the whole of this. I would write this is equal to the whole of this, then plus x inclusive. I hope this is clear. I'll see you in the next one. Bye for now.